So Dr. Aaron Birt from Solvus Global going to be talking. I began today with reference to machine learning and also talking about the importance of powder. And so it's a challenge to condense this into 10 minutes, but I told Aaron that's what I want to hear. So
perfect. Is everybody able to see this application okay? Let me make sure it's sharing right.
I can see it.
Vic, I'll look to you. Are you able to see it okay?
Yep, definitely. Yep.
Excellent. All right, so we're going to jump in here. So first of all, it's great to be here. It's no fun to be virtual, but it's honestly not so bad. It could be a lot worse, and we appreciate all of you who are on here. This is a really great turnout for a virtual event all about one technology. So it's pretty amazing to see all the folks coming together around what we're all doing. So to start, I just wanted to hit on kind of something that we had touched on about this time last year, was just the idea of kind of powder to part traceability and what that enables. So we're going to talk about it from the powder's perspective, but also from the kind of system support perspective as well, because all of these things are really, really important for ensuring that we can consistently hit the spray target metrics that we have, or maintaining the quality that we need to ensure that all of our parts are being repaired appropriately, or that they're being fabricated in a consistent manner. So a couple of really big things have happened in the last year in the world of powders for cold spray, and that's kind of independent of what's happening for additive manufacturing or other areas. But specific to the materials that we're working to get qualified or have already gotten qualified within the new ARL military standard, a couple of big things. One is the materials that are provided, the aluminums and the WIP products. These are all non-flammable, non-combustible per some recent testing that's been going on. This is a really, really big deal for getting cold spray set up anywhere in the world. So really want to emphasize that these are non-flammable, non-combustible. That's not all materials, but that is the materials that we're providing for cold spray today, and that's a combination of the raw material sources that we're using and the processing that goes into these materials. We're working on an integrated cabinet for very, very easy installation into a spray facility, so that you can keep track of your quantities in a safe and robust fashion, something that matches with all NFPA codes for fire safety and for storage and locking requirements. And then the portal for these sales is up and going, so if you need materials, powdersondemand.com is where you can go. And to try and support that and continue to build out both the materials and kind of make sure that our customers' lives are easy here, we are working to put together some customer focus sessions, so that if there's new materials that need qualified, or if there's different packaging that's required, whatever it may be, we really want to make sure that we can support the broader cold spray community needs with these types of focus sessions. So if you're interested in being involved, please reach out. We're very, very, very open to being engaged about how we build the supply chain for the cold spray community here. So one thing I wanted to touch on, just kind of as relates to the importance of paying attention to your powder and your material and how it interacts with your system, was just a scenario that we ran a test with recently, looking at two different system configurations and two different material types. And what happens is the materials, I apologize, they're actually the same materials. This is a 6061. The only difference is the size distribution, and it's only off by about 5 microns on the D10. So very, very small change in size distribution there. But the finer particles don't actually spray in the system configuration. So you try to spray through it, and you're going to clog your nozzle almost immediately. If you shift the particle size distribution up by just a fraction into the second distribution that you see, then everything sprays fine. You get your expected yield strength, your expected elongation, everything's working great. So a small shift in your powder makes all the difference in the world, and that number can even be within the bounds of most quality control systems. If your average requirement is something like 20 micron and you're plus or minus 3, plus or minus 4 micron on your D10, it's going to make a difference. And so in our world, we look at this as two approaches, right? You can tackle the powder. You can also tackle it from a system perspective. So you can modify the applicator type or the system type a little bit, go back to that same powder that you had, and you can use it in that specific system configuration because of the modifications that have been made to it. And then in yet another modification of the system or a different applicator type, you can again use the larger powders or the smaller powders, and you can get the results that you want. So all I want to highlight here is just the importance of knowing what's going into your system and what the configuration of your system is and what that material has been qualified for to begin with. Not all materials that are suitable for a helium spray are also suitable for nitrogen spray. Sometimes there's distinctions between those two that we want to make sure that we're on top of. So with regards to that, there's a couple of things that we do at Solvus a little bit differently to make sure that we're keeping tabs on that quality. So one is looking at the particle size, not just for mass distribution, but also number distribution. So that slide that I just showed a second ago talking about a 5 micron difference actually is a 30 to 50% difference in the number count of particles that are on the fine end of your distribution. So that makes a big difference when you're talking about the quality of your material. And that's something that we take very seriously in our tracking and delivering to our customers for, again, that quality control purpose so that you can know what's coming in and out of your system. A second that's just worth highlighting here is some studies that we're doing on compaction methods to simulate cold spray. So this is to simulate a bulk cold spray deposition. And what you're seeing over on the right is the percent of mass that's compacted by a high impulse puck. And so we're working on developing this tool as a rapid evaluation, rapid screening test to determine how materials will behave in a cold spray process. So this is the goal of being able to quickly analyze many different materials so that when we're trying to come up with the next formulations and the next blends, that we can provide ones that are likely to be highly sprayable in various environments. So that's another area that we're working on evaluating and developing into a little bit more. And it's also really important from the machine learning and data generation perspective because it gives us a numeric insight into how a material will behave in the cold spray process without necessarily having to cold spray it all the time. So then just real quick, the materials that are presently available and are either qualified or undergoing qualification through the ARL MILT standard, the 32495. So you can get these available and you can talk to either Gen or any of the other folks at ARL to see how those are matching in with the current QPL. And just a flash into some of the materials that are coming down the line, looking at some different steels, both alloy and stainless, nitinol powders. One material that we're really excited to roll out is with W1s. This is a high hardness tungsten carbide nickel that sprays with helium or nitrogen. So lots of different materials here that are really exciting to be pushing forward into the cold spray world. Nitinol is another one that we think can have a big impact on this community. So if you're interested in these materials or have others that you want to develop alongside of us, we're very open to co-developing and co-creating materials, something that we do very frequently with the folks at ARL. So to switch gears just a little bit, and I'm tight on time since we started just a minute here late. So talking about machine learning and how we connect it all together, we're looking at taking a kind of large-scale approach to machine learning here from the material data on your powders all the way up to the spray process. And to do that in this kind of specific example, what we're doing is basically generating a model that is able to predict and recommend processing conditions based on a given material. So if you know things about its size distribution, you know things about its material properties, you know kind of your rough system configuration, then the model can recommend the appropriate gas temperature, pressure, standoff distance to recommend for the process that you're a part of. And so what I would do here is basically simulate a theoretical model using like a one-dimensional heat transfer fluid dynamic model. We run a whole bunch of different simulations to generate a bunch of data. We take all that data and we run it through a number of different powder scenarios. So those scenarios would be different configurations, different size distributions, whatever they may be. And we go through and we optimize around a specific metric. So in this case, we optimize around critical velocity. We could optimize for cost. We could optimize for material deposition efficiency. We could optimize for hardness, whatever it may be. And you iterate through, and your model predicts for you, for any given powder distribution, et cetera, the right spray parameters to be operating at. And so in the scenario where we're just predicting velocity, we're matching within less than a standard deviation of your measured velocity as measured by a high watch velocimeter from OSAIR. And then you can take and you can simulate that same velocity distribution across many different particle sizes, again matching, for the most part, all of the different velocities at the different particle size ranges. And then you can take and you can optimize, again, specific to that critical velocity so that you can tweak your parameters just enough so that you maximize the number of particles that are in your critical velocity window across your whole size distribution. So not just one particle, but many, many particles. And so we can do that very, very quickly by using this type of machine learning approach. It's orders of magnitude faster than a MATLAB routine or any type of GPU accelerated routine. So this is leveraging theoretical data as well as physically generated data to maximize the amount of information that you can get out of your system as quickly as possible. So I just want to give a quick thanks to the folks at ARL for supporting much, if not all, of this work. It's very important for us as kind of developing all of these different capabilities and technologies that we have a strong collaboration across all the different supply chain components here. And so we're excited to be a part of that. With that, thank you all for your time here. I know we're cutting it close, so if I have a question or two, happy to answer them.
So Aaron, there's a very good talk, by the way. Can you tell the folks anything about when the national stock numbers will be issued for these powders?
Yeah. So we're going through, all the materials are qualified on the QPL. So now the next step is getting the DLA to issue those NSNs. We're looking at sometime this year is the target. There's some changes that have to be made in the QPL in order, or in the mill standard in order to make it amenable for the NSNs. But we're expecting this year to be able to roll out those, and that would make it obviously very, very straightforward for all the folks in the defense space to make those procurements.
Excellent. So one last question. What can you say about any sort of, prototype trials of the machine learning tool with the cold spray system?
Yeah, absolutely. So we're actually launching a live beta test at the Webster facility, so the cold spray synergy site. We're also launching a beta test at Worcester Polytechnic Institute, and we'll be launching internally at Solvus as well. So that'll have the full data management system so that you can pull in all of your data as well as analyze your data, process or capture data about your materials, and recommend these types of spray parameters that we just discussed. So if anybody's interested in being involved in that beta, we'd love to chat, whether it's the beta test or the full version that we're pushing out towards the end of this year. Would love to have folks that can give it a try.
Very good. Okay, so to keep us on track, I'm prepared to introduce